Okay, for the last problem, for our last example here. So if a snowboarder is traveling at 8 meters per second, how long will it take her to reach 36.0 meters per second if she can accelerate at a rate of 3.5 meters per second squared? So we have acceleration, final velocity, initial velocity, and time. So we're told right in the problem that her rate of acceleration is 3.5 meters per second squared. We are told that her final velocity that she reaches is 36.0 meters per second. Her initial velocity is 8.0 meters per second. And we need to figure out how much time she is taking. So when we look at our equation, A equals VF minus VI times by t. Again, our equation is not rearranged, so it's t equals. So that's what we're going to do. So the first thing I'm going to do, since I have t in the bottom of a fraction, I'm going to multiply both sides by t. So I'll cancel it out over there. So now I'm just left with t times by a equals final velocity minus initial velocity, or VF and VI. So now to get t by itself over here, I'm going to divide both sides by a, leaving me with this new formula. So VF minus VI all over a will equal t. So now we just need to plug in our numbers. So our final velocity, 36.0 minus 8 all over 3.5. So when I grab my handy calculator, 36 minus 8 equals 28, and then I'm going to just divide that right by the 3.5, and we get our answer to be 8. So our time is going to be 8.0 seconds. Because when we go back to look at our significant figures, 3.5 has 2, 36.0 has 3, V sub I has 2, so the smallest one of those is 2, so our answer has to have 2 sig figs. And then we are dealing in seconds because we're dealing with meters per second squared and meters per second. So when you look at the time aspect of it, we're talking about in time or in seconds, not in minutes, days, or hours.